Hello everyone, this is Dr. K. Mamata, Assistant Professor, Department of Mathematics, Vardhaman College of Engineering. In today's lecture, we are discussing about multiplication by t power n in Laplace transforms. How do we find Laplace transform of the function f of t when it is multiplied by t power n? We'll see now. Now, the statement of multiplication by t power n is, if Laplace transform of f of t equal to f of s, then Laplace transform of t power n f of t equal to minus 1 power n d power n by ds power n of f of s. So, where what is f of s? L of f of t. So, in order to find Laplace transform of t power n f of t first, we need to find Laplace transform of f of t. So, now the example based on multiplication by t power n is L of t sin square t, and the solution is, so here f of t equal to sin square t. Now using multiplication by t, I can write this function as L of t sin square t can be written as L of t into sin square t formula is 1 minus cos 2t by 2. Now using the linearity property of Laplace transform, this expression can be written as 1 by 2 into Laplace transform of t minus Laplace transform of t cos 2t. So here for this function we can apply the formula of L of t power n. What is L of t? 1 factorial by s power 1 plus 1. So which gives 1 by s square minus, here apply the formula of multiplication by t power n using Laplace transform. So what is Laplace transform of t power n into f of t? Minus 1 power n d power n by ds power n of L of f of t. Here in this formula you have to replace n with 1. So if I replace n with 1, so this term gives minus 1 power 1 d power 1 by ds power 1 of L of cos 2t. So this is equals to 1 by 2 into 1 by s square minus of minus 1 whole power 1 is minus 1. So the result will be plus 1 d by ds of L of cos 2t. So L of cos 2t is s by s square plus 2 square, that is nothing but s by s square plus 4. Now 1 by 2 into 1 by s square plus derivative of s by s square plus 4. Now apply derivative of u by v. So what is the derivative of u by v? V u dash minus u v dash by v square. So applying this derivative of u by rule for this expression, we get s square plus 1 and derivative of s becomes 1 minus s into derivative of s square plus 4 is 2s by s square plus 4 whole square. So this is equal to 1 by 2 into 1 by s square plus s square plus 4 minus 2s square by s square plus 4 whole square. This is equals to 1 by 2 into 1 by s square plus s square minus 2s square gives minus s square. So we get 4 minus s square by s square plus 4 whole square. And the next example is Laplace transform of t e power minus 2t sin 4t. We need to evaluate this problem using multiplication by t power n. Here it is given that Laplace transform of e power minus 2t t sin 4t. So first, to evaluate Laplace transform of this function, I need to apply change of. Now to evaluate the Laplace transform of the function e power minus 2t t sin 4t, first I need to apply first shifting theorem. Since the function t sin 4t is multiplied by e power minus 2t, so here in this result we need to replace s with s plus 2 according to first shifting theorem. So first I need to find Laplace transform of t sin 4t, and by applying first shifting theorem, here we need to change s with s plus 2 in this result. So I am considering this as equation 1. Now first I am considering the term L of t sin 4t. After evaluating Laplace transform of this function, in the final result I will replace s with s plus 2 as per equation 1. So using multiplication by t power n, Laplace transform of t sin 4t can be written as minus 1 power 1 d power 1 by ds power 1 of L of sin 4t. So this is equals to minus d by ds of L of sin 4t is 4 by s square plus 4 square, that is s square plus 16. By taking 4 outside we get minus 4 into d by ds of 1 by s square plus 16, and derivative of 1 by s square plus 16 is the formula of derivative of 1 by x is minus 1 by x square. So here applying the same formula we get minus 4 into derivative of 1 by s square plus 16 with respect to s gives minus 1 by s square plus 16 whole square, and inner derivative with respect to s is 2s. So the answer will be 8s by s square plus 16 whole square. So this result is for Laplace transform of t sin 4t. Now we need to substitute this result in equation 1. From equation 1 we have the term Laplace transform of e power minus 2t into t sin 4t, and this is equals to Laplace transform of t sin 4t, and in this result we need to replace s with s plus 2 by first shifting theorem. So now we know L of t sin 4t is 8s by s square plus 16 whole square, and here in this result we need to change s with s plus 2. Now changing s to s plus 2 gives the result as 8 into s plus 2 by s plus 2 whole square plus 16 whole square, and the simplification gives 8 into s plus 2 by s square plus 4s plus 4 plus 16 gives plus 20 whole square. And one more example based on multiplication by t power n is L of t square sin 80. So L of t square sin 80 equal to minus 1 whole square into d square by ds square of L of sin 80. This is equals to minus 1 whole square is 1. So we get d square by ds square of L of sin 80, and the formula for L of sin 80 is a by s square plus a square. Since a is a constant, we can write it as a into d square by ds square of 1 by s square plus a square. And now we need to differentiate this 1 by s square plus a square twice with respect to s. So this can be written as a into d by ds of 1 by s square plus a square. Since derivative of 1 by x is minus 1 by x square, applying the same formula we get the result as a into d by ds of first time differentiation of this term gives minus 1 by s square plus a square whole square. Again inner derivative with respect to s gives 2s. Now this expression can be written as minus 2a into d by ds of s by s square plus a square whole square. So one more time we have to differentiate the term s by s square plus a square whole square with respect to s, and again applying the formula of derivative of u by v. This is nothing but v u dash minus u v dash by v square. Since both numerator and denominator containing the term s, so that's why we are applying the formula of derivative of u by v for this expression. So which gives minus 2a into s square plus a square whole square into derivative of s is 1 minus s into again s square plus a square whole square derivative is 2 into s square plus a square, inner derivative with respect to s is 2s by s square plus a square whole square, again whole square gives whole power 4. So by taking s square plus a square common in the numerator we get the term s square plus a square minus 4s square into 1, as we took s square plus a square common, by s square plus a square whole power 4. The simplification of this expression gives minus 2a into a square minus 3s square by s square plus a square whole cube. And this is equals to 2a into 3s square minus a square by s square plus a square whole cube is the result. Thank you.